Hello friend, myself Prof. Sukhbur HK. Today we learn new topic hydrodynamics. In this topic we can discuss some important term in hydrodynamics. Then we can discuss two flow of fluid. First one is a streamline flow. It is also called laminar flow, and next one is a turbulent flow. Then we can discuss what I mean by critical velocity, Reynolds number, its condition, and viscosity, viscous drag, or viscous force, or velocity gradient. All these terms we can discuss one by one here. Firstly, we can discuss here what is meant by hydrodynamics. Definition: the branch of physics which deals with the study of property of a fluid in a motion is called hydrodynamics. Repeat again definition: the branch of physics which deals with the study of property of fluid in motion is called hydrodynamics. Here, study of fluid in motion is very important. In study of fluid in motion is very important. Then we can discuss some important term in a hydrodynamics. Some important term in hydrodynamics. First one is a steady flow. What is by steady flow? Definition here: flow in which measurable property such as pressure or velocity of the fluid at a given point is a constant over time is called steady flow. Repeat again definition: flow in which measurable property such as pressure or velocity of the fluid at a given point is a constant over time is called steady flow. Here steady flow means, in short, flow is a constant here. Another definition is a flow line. What I mean by flow line? Definition here: path of an individual particle in moving fluid is called as flow line. Path of an individual particle in a moving fluid is called flow line. This flow line shown in this figure, see here, this is a first flow line, this is a flow line, this is a flow line, this is a flow line. All these are flow line because this is a path of an individual particle in moving fluid, hence it is called as a flow line. Then next one is a streamline flow. What do you mean by streamline flow? The curve, what is meant by streamline? Not streamline flow, streamline. The curve whose tangent at any point in the flow is in the direction of the velocity of the flow at that point is called a streamline. The curve whose tangent at any point in the flow is in the direction of the velocity of the flow at that point is called as a streamline. Some note prepare here. Streamline and flow line are identical for a steady flow. The streamline and flow line both are identical for a steady flow. If flow is steady, that time streamline and flow line are identical. And another term is a flow tube. What do you mean by flow tube? Definition here: an imaginary bundle of a flow line bound by an imaginary wall is called flow tube. An imaginary bundle of flow line bound by an imaginary wall is called flow tube. For a steady flow, the fluid cannot cross the wall of a flow tube. Fluid in adjacent flow tube cannot mix. This flow tube you can see here. This is a flow tube. This is a flow tube. This is a imaginary bundle of flow of line bound by this imaginary wall. This is a imaginary wall. It's called flow tube. This fluid in adjacent flow tube cannot mix, or two or more flow tube cannot be mixed here. Then next term is a streamline. A streamline also called laminar flow. Definition here: a steady flow in which adjacent layer of a fluid move smoothly over each other is called streamline or laminar flow. A steady flow in which adjacent layer of a fluid move smoothly over each other is called streamline or laminar flow. Another definition here: smooth flow of fluid which velocity less than a certain limiting value. This is the limiting value considered here. Critical velocity is called streamline flow or laminar flow. For example of a streamline flow is a steady flow of a river. Steady flow of a river. Then we can discuss here characteristic of streamline flow. First characteristic: the tangent at any point of the streamline given the direction of velocity of the liquid at that point. Second characteristic is two streamline cannot intersect. Third characteristic: at particular point of the streamline the velocity of liquid is a constant. Here velocity of liquid is constant. However, at different point of the streamline the velocity may be different. And fourth characteristic: streamline which are closely spaced represent the faster flow of the liquid. This is a very important characteristic of streamline flow. Streamline which are closely spaced represent the faster flow of the liquid. This is a important characteristic of a streamline flow. Some question asked on this topic. First one: what is a hydrodynamics, then define the following term. First one is a steady flow, flow line, streamline, flow tube, and another question asked on streamline or laminar flow is what is the streamline or laminar flow of a liquid, and next flow is a turbulent flow. Another type of a flow is a turbulent flow. Here streamline flow shows in this figure here. This is a streamline flow. Next one is a turbulent flow. Next flow, turbulent flow definition. The irregular and unsteady flow of a fluid when its velocity increases beyond critical velocity is called turbulent flow. The irregular and unsteady flow of a fluid when its velocity increases beyond critical velocity is called turbulent flow. Or definition here, another definition, a flow at very high flow rate so that there is no steady flow and flow pattern changes continuously. This flow is called as a turbulent flow. And another interesting definition here, if liquid is in streamline flow and the velocity of the flow is gradually increased, then after certain critical velocity flow become irregular, we also called zigzag. Such a flow is called turbulent flow. For example, example of a turbulent flow is a flooded river flow. Flooded river flow. This is a turbulent flow. See in this diagram. Some question asked on this topic, what is turbulent flow? Then we can discuss here some property of a turbulent flow. First is, we can see this diagram. Then we can prepare some property of a turbulent flow. First property, flow is irregular and the path is a zigzag. We can see here this path is a zigzag or flow is a irregular here. Second property, velocity of flowing liquid is more than critical velocity. Here velocity of flowing this liquid is more than critical velocity. And third property, velocity of fluid at a point is not a constant. Velocity of fluid at point is not constant. Density is effective in this flow. Density is effective in this flow. And another fifth one property, at some point liquid may have rotational motion which gives rise to eddies. At some points liquid may have rotational motion which gives rise to eddies. This is a property of a turbulent flow. Then we can discuss here distinguish between streamline flow and turbulent flow. See these charts. First one is a streamline flow. Definition we can prepare here. The smooth flow of a fluid with velocity smaller than certain critical velocity, that is a limiting value of velocity, is called streamline flow or laminar flow of a fluid. Another definition of a turbulent flow: the irregular and unsteady flow of a fluid when its velocity increase beyond critical velocity is called turbulent flow. Second point of distinguish between streamline flow and turbulent flow. In a streamline flow, velocity of fluid at a given point is always constant. Velocity of fluid at a given point is constant. And another one, in a turbulent flow, the velocity of fluid at any point does not remain constant. And third point here, two streamline two streamline can never intersect. They are always parallel. Two streamline can never intersect. That is, they are always parallel. In turbulent flow, at some point, the fluid may have a rotational motion which gives rise to eddies. And last point, in streamline flow over a plane surface can assume to be divided into number of plane layers. In a flow of liquid through a pipe, uniform cross-sectional area, all the streamline will be parallel to the axis of tube. And in a turbulent flow, flow tube loses its order and particle move in a random direction. This is a distinguish between streamline flow and turbulent flow. Then next point we can discuss here. What do you mean by critical velocity? Definition here: the velocity beyond which is a streamline flow become turbulent is called critical velocity. Simple definition prepare here. What do you mean by critical velocity? The velocity beyond which a streamline flow became a turbulent is called critical velocity. According to Ashburn Reynolds, Ashburn's Reynolds, the critical velocity is given by V suffix c be the critical velocity is given by in formula V suffix c is equal to R suffix n into eta upon rho into small d. Here V suffix c critical velocity of fluid, R suffix n Reynolds number, eta be the coefficient of viscosity, rho be the density of fluid, and small d be the diameter of the tube. Then critical velocity become here V suffix c is equal to R suffix n into eta into rho into small d. This is a critical velocity. Then next point we can discuss here a Reynolds number. Reynolds number given here. Reynolds number given here. R suffix n r suffix n is equal to v suffix c into rho into d upon eta. Then we can prepare here simple definition. The dimensionless number which having value, this value is n is equal to n suffix c rho into d upon eta, is called a Reynolds number. Some term included in Reynolds number here. First one, v suffix c, critical velocity of a fluid, rho be the density of liquid, d be the diameter of tube, and eta coefficient of a viscosity. Then question asked on this topic, what is Reynolds number? Explain how Reynolds number is used to determine the nature of flow of liquid. Then some condition. Some notes prepare here. First note, it is a pure number which determines the nature of flow of liquid through a pipe. It has no unit and dimension, hence it is called as a pure number. Some condition given here, or Reynolds number is used to determine nature of liquid. First condition here, if value of Rn is less than 1000, the flow of liquid is a streamline or laminar. If value of Rn is Reynolds number is less than 100, the flow of liquid is streamline or laminar. Second condition, if R suffix n lie between 1000 to 2000, then the laminar flow may be changed to the turbulent flow. The value of Reynolds number lie between 1000 to 2000, then laminar flow may change to the turbulent flow. And another condition, if value of Reynolds number is greater than 2000, the flow of liquid is turbulent. The flow of liquid is turbulent. These all condition explain the Reynolds number is used to determine nature of a fluid. Then another interesting term we can discuss here, what is meant by viscosity. Another interesting property of a fluid is a viscosity. Definition: the property of fluid by virtue of which the relative motion between different layers of a fluid experience a dragging force is called viscosity. The property of fluid by virtue of which the relative motion between different layers of a fluid experience a dragging force is called viscosity. Another definition prepare here. Simple definition: the property by virtue of which fluid oppose a relative motion between adjacent layer of a fluid is called viscosity. The property by virtue of which fluid oppose a relative motion between adjacent layer of a fluid is called viscosity. Here we prefer more the opposition to the motion, higher is a viscous property. For example here, example of viscosity: honey is more viscous than water. Honey is more viscous than water. So, some simple example we can done here. When we pour water from a glass, it flows freely and quickly, but when we pour syrup or honey, it flows slowly and strikes to the container. The difference is due to fluid friction. This friction is both within the fluid itself and between the fluid and the surrounding. This property of fluid is called as a viscosity. Here, water has low viscosity, whereas syrup or honey has high viscosity. Then we can prepare here. More the opposition of the motion, higher is the viscous property. Some important of a viscosity here. First important, used to detect blood corpuscle deficiency. Second important, use in blood flow through the arteries. Third important of viscosity, viscosity of oil help in apply breaking brakes. And another, in general liquid are more viscous than gases. This is a important of a viscosity. Then another definition we discuss here, viscous drag or viscous force. Definition: the tangential force act on adjacent layer of a fluid which oppose the relative motion between the layer of fluid or gases is called viscous drag or viscous force. The tangential force act on adjacent layer of a fluid which oppose relative motion between the layer of liquid or gas is called viscous drag or viscous force. Then we can discuss velocity gradient. Definition here: the rate of change of velocity considered as dv with the distance dx measured from the stationary layer is called the velocity gradient. Definition: the rate of change of velocity with distance measured from a stationary layer is called the velocity gradient. Velocity gradient. Now we consider here, see this diagram. If v and v plus dv are the velocity of layer of liquid at distance x, and x plus delta x represent from the bottom, then the velocity gradient is given here. Velocity gradient given here. Velocity gradient v plus dv minus v upon x plus dx minus x. Here x gets cancelled, v gets cancelled, remaining what? Velocity gradient is equal to dv upon dx, that is rate of change of velocity with the distance measured from a stationary layer is called the velocity gradient. Some notes prepare here. To overcome the viscous drag, and this viscous drag considered as a viscous force, an external force is required. Second notes, viscous force depend upon the area of layer and velocity gradient. Velocity gradient. Some question asked on this topic. Define velocity gradient. In this way we can complete some important concept or important term in hydrodynamics. Firstly, we discussed steady flow, flow line, streamline, flow tube. Then we can discuss tube flow of a liquids. First one, streamline or laminar flow. Then we can distinguish between streamline and turbulent flow. Then we can discuss critical velocity, Reynolds number, viscosity, its important, viscous track, and velocity gradients. Today we stop here. Thank you.